We usually think math is just numbers.
Yeah.
Numbers, right? Equations on a blackboard.
Yeah, something kind of abstract, maybe stuck in the classroom.
Exactly. But what if it's actually like the basic language behind, well, everything? How our minds learn, the tech we're using right this second.
That shift in perspective is, well, it's really what our source material gets into. It's called Science of Patterns and Calculation, mathematics at the core of learnography and technology.
Right, by Shiva Narayan.
Mm-hmm.
Yeah.
And it argues math it's way more than a school subject. It calls it the universal science of patterns, templates, and calculation. The stuff shaping reality.
Totally. And that's what this deep dive is all about, exploring that huge role, especially how it impacts learnography, which sounds interesting. We'll definitely unpack that, and of course, technology.
Yeah.
So our mission today, for everyone listening, is to pull out the key ideas from this article, show how math is like this hidden blueprint for, our minds and the machines we build.
And it paints this really connected picture. The article calls math the formatting language of space, objects, and time.
Formatting language.
Okay.
Yeah, think about the examples it gives, like the way atoms line up in molecules or how planets orbit stars. Even how our brain cells connect. It argues that's all governed by, well, mathematical rules.
Which flows perfectly into this learnography idea. Now, that term might be new for folks. How does the article define it, basically?
It calls it the applied science of learning.
Yeah.
Specifically, using the brain's motor and memory circuits to build brain page maps and modules.
Brain page maps and modules. Okay, so like learning by doing and remembering, building knowledge structures in our heads.
Exactly. And the math connection is right there. The learnography the article stresses is inherently patterned, procedural, logical, and repeatable.
So it works like math does. Step-by-step, logical sequences.
Pretty much. Like an algorithm running or a sequence unfolding. And then there's technology.
Yes. Tech. The article's pretty blunt about that, isn't it?
It is. Calls it the brainchild of mathematics. Flat out says all our tech, AI, the phone in your pocket, it's all rooted in mathematical patterns, structured templates, and systematic calculation.
So, bottom line, no math, no tech. It's fundamental.
That's the core argument, and it breaks math down into these 3 pillars: patterns, templates, and calculation.
Okay, pillars. Let's start with patterns then. What's the essence there?
Well, math is basically about spotting these recurring, predictable arrangements, finding them, describing them, working with them.
Like the examples you mentioned earlier, the sunflower seeds.
Right, the Fibonacci sequence in sunflowers, the article mentions that. Or snowflake symmetry, even sine waves in sound.
Those aren't just random pretty things.
No, the article frames them as math in action, shaping the world. And this pattern recognition, it's crucial for learnography.
How so?
Well, the source says when learners spot patterns in, say, an equation or a shape, it helps them grasp the structure. It lets the brain kind of hook the new information onto existing pathways more efficiently.
Makes sense. So patterns help build those mental structures. What about the second pillar? Templates.
Templates are described as these predefined structures that help organize and apply knowledge.
Like a formula. Or a method for solving a specific problem type.
Exactly. Formulas, algorithms, problem-solving strategies, frameworks you can just plug things into.
And they make things more efficient, I guess.
Hugely efficient. For students, for innovators, templates mean you're not reinventing the wheel every time. You process faster, make logical choices, tackle complexity.
And learnography uses these too. Task templates and learning templates.
The article mentions those, so maybe a template for learning a physical skill, the sequence of moves, or a template for a math problem, a step-by-step method. They help build those knowledge modules.
Okay, I can see that. And the tech parallel.
Oh, it's very direct. Think about coding structures, right? It's the basic architecture.
Yeah.
Or data models that organize info, or blueprints for buildings.
Right, they're all templates.
Yeah, they take the logical plan and give it the structure needed to become actual software or hardware.
Got it. Okay, pillar number 3, calculation.
The article calls this the executive function of mathematics.
Executive function, like the CEO of math.
Sort of. It's the part that processes values, solves the problems, makes the decisions happen, the active doing bit, both in our heads and in physical actions.
And it mentions motor calculation and learnography. What's that about?
Yeah, that's interesting. It's the idea that when you physically write out a solution or work through steps, you engage motor circuits as well as cognitive ones.
So writing helps you remember better.
That's the idea. Creates stronger memory traces, makes learning more active, less passive.
Okay, and calculation in tech is
Well, everywhere, right.
Absolutely everywhere, from the tiniest level processing bits and bytes up to, super complex algorithms for graphics rendering or financial trading. Calculation is the engine.
Hmm. So patterns, templates, calculation. The three pillars. Right. But the article also talks about how math formats our world, functional space, tangible objects, and the flow of time.
Okay, break that down. Space, objects, time.
It connects geometry to defining space, algebra to understanding objects and how they relate, and calculus, well, calculus is for handling change over time.
Geometry, algebra, calculus. The big three.
And this ties directly into something called the SOTIM framework in learnography.
So let me guess. Space, object, time.
Instance module, yeah. Space, object, time, instance module. It's a framework in learnography for organizing knowledge transfer. It aligns really well with those mathematical areas.
So learning math actually makes you better at thinking about space and time?
The source argues yes. It boosts what it calls spatial temporal intelligence. Grappling with geometry, algebra, calculus helps you visualize space, manipulate objects mentally, measure change.
And you see this in technology constantly.
Oh, definitely. Architectural software manipulating virtual space. Animation tools, objects moving through time. Game engines creating whole worlds. Even AI making predictions based on how things behave over time. It's all math formatting reality.
This is deep stuff.
Yeah.
And it leads into these 7 mathematical dimensions of learnography, the article outlines.
Right. This part is fascinating because it really shows math woven into the process of learning itself. The first one is the definition spectrum.
Definition spectrum. Math parallel.
Think axioms, theories, precise definitions in math, the absolute fundamentals.
And in learnography, its function is
Developing that deep understanding like a third eye for the subject, it builds the foundation, the mother book, as they call it, and defines the scope of the curriculum.
Okay, dimension 1. What's next?
Dimension 2, question matrix. The parallel here is like function matrices in algebra or programming.
So about asking questions.
Exactly. Forming good questions, effective queries. This builds the father book, the book of inquiry, and shapes the learning path.
Mother book of understanding. Father book of inquiry. Interesting framing. Dimension 3.
The block solver. Think problem-solving steps or worked examples in math textbooks.
Okay.
In learnography, this is about the brain-breaking tasks into manageable chunks or blocks. You solve one block, transfer that knowledge, move to the next.
Makes learning less overwhelming, I suppose?
Precisely. Number 4 is the hippocampus.
Hippo, like hippocampus.
Well, perihippocampal gyrus specifically, but yeah, related to memory navigation. The math parallel is graph theory or logic mapping how things connect.
So the hippocampus is like our brain's internal search engine.
That's a great way to put it. It guides how we find and retrieve knowledge we've stored.
Cool. Dimension 5.
Module builder. The comparison is to modular arithmetic or modular design, building things from distinct parts.
And in learnography.
This is where you construct the actual solutions or understandings, building those knowledge modules, especially for things involving visual or motor skills, putting the pieces together.
Right, we're up to 6.
Task formator. This is linked to high-level algorithms or templates.
Okay, and its role.
It draws on visual and spatial learning, activating the visual cortex and memory to create those brain page modules we talked about earlier. It deals with formatting knowledge about functional objects, theories, laws, proofs, derivations, etc. The article even suggests it might encourage risk-taking in learners by providing structure.
Interesting connection. And the last one, number 7.
Dark knowledge.
Dark knowledge. Sounds mysterious.
It kind of is. The parallel is to those intuitive leaps in conceptual math, the aha moments.
So the creative spark, discovery.
Exactly. It's the research dimension, finding new knowledge, new theories. It apparently activates the brain's genius area, precuneus, retrosplenial cortex, areas linked to episodic memory, self-reflection, even consciousness.
Wow. So these 7 dimensions, they all trace back to mathematical ways of thinking.
That's the argument. It shows learnography isn't just random, it's a functional system with this deep mathematical structure guiding how we transfer knowledge, especially through motor learning.
It really reframes learning itself. Okay, so we've covered learnography, but let's swing back explicitly to technology. The article's stance is pretty clear.
Unequivocal, really. All technological innovation is an application of mathematics. Full stop.
And it gives examples across the board, right?
Yeah, machine learning algorithms, app programming logic, building design calculations, spaceship trajectories, you name it.
And those pillars, patterns, templates, calculations, they apply here too.
Absolutely. Patterns guide design principles. Templates provide the development structures, calculations ensure everything actually works. It's the same foundation.
Even the really advanced stuff like AI and neural networks.
Definitely. The article points out they borrow directly from math concepts like graph theory, calculus, probability. Their very structure is mathematical.
And every line of code.
Relies on logic gates, number systems, algorithms, basic math concepts powering everything digital. It's math all the way down.
So wrapping this all up then, the big takeaway from this deep dive is math isn't just math class.
Not at all. It's this universal framework. It shapes how we learn, how we innovate, how we build our world. From learnography inside our heads to the tech in our hands.
And it all boils down to those three core ideas.
Patterns, templates, and calculation.
Mm-hmm.
Recognizing patterns, using templates, executing calculations. That's the engine, according to the source.
So for everyone listening, hopefully this sheds some light on just how powerful math is, maybe in ways you hadn't quite considered. It's more fundamental than we often realize.
Yeah, and the article ends with this sort of call to action, which is actually pretty practical.
Oh yeah, like what?
It encourages you to actively look for patterns in everyday life, to consciously try and build structured knowledge modules, those brain pages, and to use calculation and logic deliberately when solving problems.
Be more mathematical in daily life, essentially.
Kind of. And also to explore those learnography dimensions. See learning as this active, hands-on journey, not just passively absorbing stuff.
Makes sense. Embrace the process.
Right. Let math be the engine for your learning, the map for creativity, the foundation for, well, whatever you want to achieve.
I like the quote you pulled earlier. Don't just study math, experience it, apply it, and innovate with it.
Exactly. The final thought is almost an invitation. Be the architect of your own learnography. Be the innovator of tomorrow. And remember,
Patterns, templates, calculation.
power it all. Learning and innovation.
That was a deep dive into science of patterns in calculation, mathematics at the core of learnography and technology by Shiva Narayan, which you can find on the Takshila page. Definitely worth checking out the Takshila page for more on system learnography.
Absolutely. And maybe just notice the math around you today. It's kind of everywhere once you start looking.